class. Today we want to continue our work with the trigonometric identities. And we want to learn some of the new identities for addition and subtraction. Yesterday we learned the sum and difference identities in lesson 5.3. That being that the cosine of a minus b is the cosine of a cosine of b plus sine a sine b. And cosine a plus b, cosine a cosine b minus sine a sine b. Today we're going to learn sum and difference identities for the sine and tangent. So the work that we're going to do today is going to be very similar to what we did in lesson 5.3 once we learn what the identities are. So to start with, we're going to work with sine of a plus b. Well, if you remember by the cofunctions that we learned yesterday, the fact that the sine of a is the cosine of its complement. So therefore, the sine of a plus b is the cosine of 90 minus a plus b. Well, if we go ahead and distribute that minus in, we get minus a minus b. And then we're going to regroup these, turning this into cosine of 90 minus a minus b. And then we can use our difference identity for cosine that we had yesterday. Cosine of 90 minus a, cosine of b, plus sine of 90 minus a times the sine of b. And then our cofunctions, remembering that the cosine of 90 minus a is the sine of a, so that's just making a substitution. And the sine of 90 minus a is the same as the cosine of a. So we make a substitution there, and we get the new identity, the sine of a plus b equals sine of a cosine of b plus cosine of a times the sine of b. Next up, we'll do the difference identity for sine. Similar to how we learned the difference identity for cosine yesterday, the sine of a minus b, well, a minus b can be thought of as a plus the opposite of b. So then, using the new ratio we just found, new identity we just found, we have sine of a cosine of negative b plus cosine of a times the sine of negative b. And remembering our even and odd identities, the fact that the cosine of negative b equals the cosine of b, so we make a substitution there. And the sine of negative b is the opposite of the sine of b, which is our substitution there. And then we simply pull that minus out to the front, and we get the new identity, sine of a minus b equals sine of a cosine b minus cosine a sine b. So if you haven't already, get your flip books out, pause the video, and go ahead and write these two new identities that you have underneath the addition and subtraction tab. Next up, we do have sum and differences for tangent, and I'm not going to go through deriving them like I did for the sines and cosines just because it's a little bit complicated. We're just going to go ahead and give them to you. The tangent of a plus b, well, that's the tangent of a plus the tangent of b divided by 1 minus tangent of a times tangent b. And the tangent of a minus b, tangent of a minus tangent of b over 1 plus tan a times tan b. So pause the video to make sure and write down these two identities. So you now should have 6 addition and subtraction identities. 2 for sine, 2 for tangent, 2 for cosine. Next, we're going to do the examples, and these are just like we did the examples yesterday with cosine in lesson 5.3. And again, I'm going to write these here. If you have not committed these to memory, you really need to, because we use these 9 trig identities or trig ratios so much that it's really, really important and a benefit for you going forward if you know what they are. So 30 degrees, of course, is pi over 6 in radians. 45 degrees, which is pi over 4. And 60 degrees, which is pi over 3. Remembering that the sine of 30 is a half, which is the same as the cosine of its complement. Sine of 45 is square root of 2 over 2. Cosine of 45 also square root of 2 over 2, which makes the tangent 1. Sine of 60 is square root of 3 over 2, which is the same as the cosine of 30. And then the tangent of 30 square root of 3 over 3, and the tangent of 60 square root of 3. Again, if you don't have those 9 down, make sure you write them down, put them in your flip book somewhere. the more of those that you memorize and know and just automatically know that the sine of 30 is a half is going to be hugely beneficial for you. So, just like we did yesterday, we want to find the exact value, which means no calculators. We're not going to punch this in and hit the sine key. We're going to use our identities to find this. So, we have to express 75 using two of these three that we know up here, and a sum or a difference, so that means we'll express 75 as 45 plus 30. By the sum of the sine identity, that's the sine of 45, cosine of 30, plus the cosine of 45, times the sine of 30. I'm going to go ahead and move this to the side so I got a little bit more room to work. Sine of 45, the value that we have memorized, hopefully by now, square root of 2 over 2. Cosine of 30, square root of 3 over 2. Cosine of 45, square root of 2 over 2, and the sine of 30 is 1/2. Square root of 6 over 4, plus the square root of 2 over 4. And as we said in lesson 5.3 when we did the sum and difference for cosine, most of these answers are going to come up to be some form of that. In our second example, we have the tangent of 7 pi over 12. So again, we need to come up with a sum or difference. So I'm going to do 4 pi over 12 plus 3 pi over 12. Knowing that 4 pi over 12 reduces down to pi over 3. And that becomes pi over 4. So then I'm going to go back to my formula. Tangent of A is pi over 3, plus the tangent of B, that's pi over 4. 1 minus tangent of pi over 3 times the tangent of pi over 4. Again, that's just straight up the identity, tangent of A plus B. Now we'll go to our values. So the tangent of pi over 3, well, that's square root of 3. Tangent of pi over 4 is 1. And again, that's square root of 3, and that's 1. So that's going to give us, if I rearrange this, always putting the radical second so we make sure we don't lose it. 1 plus the square root of 3 over 1 minus the square root of 3. But remember, we can't have a radical in the bottom, so we're going to have to rationalize it. So we're going to multiply by its conjugate, which is 1 plus the square root of 3. Same A and B, differing by the sign of the second term. And if we do it to the denominator, we got to do it to the numerator. So I'm going to keep going sideways on this. So at the bottom, we're taking a sum times a difference, so that's going to be a squared, 1, minus b squared, which is 3, which will make that be negative 2. At the top, we got a FOIL, so 1 times 1 is 1. 1 times square root of 3 is square root of 3. We get another square root of 3 when we do the inner, so that's 2 square root of 3. And then square root of 3 times square root of 3 is 3. Combining our like terms, 1 plus 3 is 4. And then we can divide both of those by negative 2, so we end up getting a final answer of negative 2 minus square root of 3 after we rationalize it. Again, I'll highlight my answers as we go on these today. Finally, the last example here, they want you to recognize that it's the sine, cosine. So this is the difference identity. So it's sine of 40 minus the sine of 160. So that's the sine of negative 120. And again, by your even-odd identities, the sine of negative theta is the opposite of the sine of theta. So that's going to make this the opposite of the sine of 120 degrees. 120, if I do a quick conversion to radians, becomes 2 pi over 3, which means that it's going to have the exact same sine ratio that pi over 3 does. So that's going to be negative square root of 3 over 2. 120 happens to be in the second quadrant where the sign is positive. So our final answer becomes negative square root of 3 over 2. Again, very similar to the work we did yesterday with the cosine sum and difference. We just use sines and tangents. In example 2, they want us to write each function as an expression involving functions of theta alone. Meaning, they don't want, here we have like a sum with theta, 30 plus theta. We just want it to be theta. So it's not terribly difficult. Basically, it's just asking us to use the identities. So the sine of 30 plus theta, sine of 30 cosine of theta, plus cosine of 30 sine theta. Again, really got to know those values. So that's 1/2 cosine theta plus square root of 3 over 2 times the sine of theta. That makes this cosine of theta over 2 plus square root of 3 times the sine of theta over 2. And since they both have the same denominator of 2, we can write this as a simplified single expression. Cosine of theta plus square root of 3 times the sine of theta over 2. Continuing, tangent of 45 minus theta. So again, we go back and if we need to, we can rush up on our tangent ratios, tan A minus tan B. So the tan of 45 minus the tan of theta over 1 plus the tan of 45 times the tan of theta. Tan of 45 is 1. Making that substitution here. And then I'm just going to clean this up because we, of course, would never show a 1 times anything because we all know that's really the tangent of theta. Again, we'll highlight the answers so we know that's what we have. And then finally, our last example in this, again, it's a difference identity for sine. So that's the sine of 180 cosine of theta minus the cosine of 180 times the sine of theta. Let me draw a quick little unit circle here. Here's 180 degrees, which is the negative x-axis. So the sine of 180 is the y-coordinate 0 times the cosine of theta. The cosine of 180 is the x-coordinate negative 1 times the sine of theta. That's nothing. So negative times negative becomes positive, and our answer is just sine of theta. Again, if you need to, at any point in time, pause the video, and then you can go back and look at what the notes are. Example 3, similar to what we did yesterday in the fact that we have to find some of the additional information that we're going to need. So we're given that the sine of theta is 4/5, or sine of a, is 4/5, and pi over 2 is less than a, which is less than pi. That tells me that that's in quadrant 2. Again, your unit circle, here's 0, here's 90 degrees or pi over 2, here's 180 degrees or pi, 3 pi over 2, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Also know that the cosine of b is negative 5/13. B is between pi and 3 pi over 2. Well, that places that into quadrant 3. So sine of a plus b, of course, is sine of a cosine of b plus the cosine of a times the sine of b. Sine of a we know. We're given that it's 4/5. Cosine of b, we know. We're given it's negative 5/13. We don't know the cosine of a. Now, if you remember when we talked about the identities, I said there's one identity that's huge that we use all the time in trig, and that is that identity of sine squared. Get my pen back here. Sine squared plus cosine squared equals 1. So we can find the cosine of a. or excuse me, the cosine of a, because we know the sine of a. So that's 4/5 squared, which is 16/25. Once you do these for a while, you get really, really comfortable, and you'll recognize, if you know your Pythagorean triples, knowing the 3, 4, 5. So 1 minus 16/25 becomes 9/25, and then we'll square root, and we get the cosine of a is 3/5. And since a is in quadrant 2, where the cosine is negative, we'll do the very, very same thing then to find the sine of b. Sine squared b plus cosine squared b equals 1. And again, b was negative 5/13. If you can recognize that's a Pythagorean triple of 5, 12, 13, I'm going to go ahead and work this out just so we have the whole solution. When I subtract that 25 over 169 over, it's 144. And then we'll square root to get that the sine of b is 12/13. And since b is in quadrant 3, also going to be negative. Now, just like similar to how we did yesterday, I realize that when I'm multiplying, I can cancel out the 5 and the negative 5. But I'm going to be adding these fractions together, and I need common denominators. So I notice that my denominators are 5 times 13 and 5 times 13. So I'm not going to cancel anything out because I want them to stay the same. So that becomes negative 20 over 65. And here becomes 36 over 65. Then I can add the numerators together, and my final answer for the sine of a plus b becomes 16 over 65. Next up is tangent of a plus b. So that identity says it's the tangent of a plus the tangent of b, all over 1 minus tangent of a times tangent of b. And again, I'll go back and make sure. It's the sum. So here you can see that sum identity. Now, again, we don't know what the tangent of a is, but we know, I'll change out of a different color here to show you where I'm getting the answer from. We have that quotient identity that the tangent of a is the sine of a over the cosine of a. Well, we were given the sine of a is 4/5. We found the cosine of a is negative 3/5. Cancel out your common denominators of 5. Tangent of a is negative 4/3. Similarly, we don't know the tangent of b, but we know the sine of b, negative 12 over 13, and we know the cosine of b, negative 5 over 13. Cancel off those common denominators of 13. Tangent of b is 12/5. So I'll go ahead and fill in all this information. So I think I can squeeze this if I go to the right. Numerator, we're adding these together. So that means we're going to have a common denominator, which would be 3 and 5 would be 15. So it's going to be negative 20 over 15 plus 36 over 15. Let me go ahead and multiply this bottom out together. And then this is going to become 48 over 15, and negative minus times a negative makes it a positive. Here's where I'm going to go right. So that's going to become 16 over 15. And this is going to become 15 over 15. So 15 plus 48 makes 63 over 15. Just like we did here, the common denominator will cancel. And the tangent of A plus B is 16 over 63. Now for the last part. Where is the quadrant of A plus B? Well, the quadrant of A plus B, you have to remember that mnemonic that we talked about in class is that all students turn crazy. Notice that the sine of A plus B is positive. The tangent of A plus B is positive, so we need a quadrant. That means that A plus B is in a quadrant where both the sine and the tangent are both positive, and that's in the all quadrant. Therefore, A plus B has to equal 1. Finally, our last example of the day, we'd like to be able to verify an identity. Similar to the work that we did in lesson 5.2, where we're going to take one side of this equation, transform it into the other. So again, as we look at this, the easiest thing is the cosine of theta. So that's our goal, is to use identities and transform the left side into cosine theta. Not necessarily hard in this case. So we have the sum of sines, so that's the sine of pi over 6 times the cosine of theta, plus the cosine of pi over 6 times the sine of theta. Then we have a cosine sum, so that's cosine of A, cosine of B, minus the sine of A, times the sine of B. In this case, A is pi over 3 and B is theta. Again, we're not touching the right side. The right side's our goal. So we don't want to do anything to change that. We want to keep that goal in mind for what we're trying to get. Sine of pi over 6, again, you need to know these 9. That's 1/2. Cosine of theta. That's square root of 3 over 2 times the sine of theta. I'm just substituting in the values. Cosine of pi over 3, that's 1/2. Let me make that look a little clearer because I screwed up. And then sine of pi over 3, well, that's square root of 3 over 2 times the sine of theta. Now, we're going to come up with our like terms. So we have 1/2 cosine theta and 1/2 cosine theta. That's 1 cosine theta because 1/2 plus 1/2. Square root of 3 over 2 minus square root of 3 over 2, those are like terms. Well, that's 0. And 1 times the cosine of theta would just be cosine of theta. Adding 0 doesn't change it. So thus, we have taken the left side, the more complicated side, and using identities, transformed it into the right side, thus verifying that that is an identity. And that is how you do lesson 5-4.